it's actually much more simple, I think, than some people were thinking. Okay, cell body 1, cell body 2, cell body 3, bang. So, okay? Are we okay with that? Cool. Is that, yeah.
Just to make sure, when we're looking at the spinal-reticular, spinal-mesencephalic, spinothalamic.
Okay, so what's happening here? This is coming up, and it's sending a branch off. We come up here. This is coming up. It's sending a branch off. There are other signaling modalities going on, but the secondary neuron is, the third order neuron really is up there.
So that's what you want us to know.
That's what I want you to remember.
Okay.
Do you have to remember for these that we have other synapses? Sure, you should know that.
Okay.
However, when we talk about the anterolateral column and we talk about 3 orders of neurons, we are literally talking about the first one coming in, the second one in the cord, the third one in the thalamus. So we're going to look at what's going on here in a similar way to looking at what went on with motor loss. And we're going to see some complexities here. And one of the reasons we're going to see complexities has to do with the differences between the posterior column. I really wish I had these a couple slides side by side. The differences between the posterior column and the anterolateral column. So let's just look at what's coming in at the lumbar enlargement here. Okay? With the anterolateral, it's in blue, it comes in, it synapses, it immediately crosses and goes up. With the posterior column, it comes in, it ascends, it synapses, crosses over, and goes up. It's critical to be able to differentiate those. Because when we have trauma in here, trauma is going to affect the 2 of these systems differently until you are superior to the cervical enlargement. Okay? Come in, cross over, go on up. Now it's only at this point that our signal coming in from here has crossed over. Do you see that? This is obnoxiously complicated, okay? Because your signals in the cervical enlargement and in the lumbar enlargement are crossing over at different places. You're following that? You see what I mean? Or you lost it this way. This is the right time to say, Kelv, I'm lost. No? We're cool. Yeah?
So you're talking about the anterior laterals already crossing over, is what you're saying, right?
So the anterolateral, and let's look at the lumbar cord, okay? Anterolateral comes in, crosses over. So if I have trauma to one side or the other of the cord, I'm not going, let's say I have trauma over here. I'm not going to affect the anterolateral over here, but I am going to affect the posterior column. So depending on where a lesion is and the extent of the lesion, you can affect either the posterior column or the anterolateral column, or occasionally both. Does that make sense?
Yes.
Okay. All right. Here is another thing you should really work on in great detail. Now, this one automatically is showing you everything. It's showing you both sides. You know, it's hard to separate these out because of the complexities of crossing over. You know, with motor, it's simple. We cross over at one spot, everything from the right side goes to the left side. With somatosensation, depending on where you are in the chord, you've either decussed already or you haven't. So that we get signals, you know, pain versus touch. You might lose touch and still have pain sensation. So if I've lost touch, boy, that's reality. We're in the posterior column. All right, posterior column. So if I have damage here, which is in the low back, unilateral on one side, okay, so I have a lesion here. What do I lose? I lose pain, temperature, and touch on one side, and on the other side, I lose vibration, position, and touch. Oh, darn. This gets obnoxiously complicated. It is. This is one of those times when I use the term obnoxious, and I mean it. You have to really pay attention to where the damage is, number one. Number two, you have to really know how these pathways work and travel. Because I'm going to ask you a question that says, oh, you have a patient. They've lost pain sensation in their right ankle. They've lost, I don't know, what could I ask you? Position sense, touch, vibration sense in their left ankle. Where's the problem? Oh, sure. Pain. We've lost this pathway. Don't think of this as a pathway. We come in, we synapse, we go up, we synapse, we're there. We come in, we don't synapse, we go up. Oh, the problem has got to be between the cervical enlargement and the lumbar enlargement. Bang. That's it. Do you see the complexity and the problem that we are going to face as we look at this? It's going to get to be a little crazy. Let's start with some simple ones. Total loss of sensation, unilateral on the right side. I really have to think about that. We all know I have left-right issues, right? I mean, I have no idea what the right side is. So this person has no somatosensation on the right side of their body. Now, two options here. Number one, we have global cortical loss. We've lost the somatosensory cortex from the face to the leg. Or we have a thalamic lesion. The cortical damage or the thalamic lesion have to be on the contralateral side. Now, please note what you're seeing here. Once you get into the thalamus, you know, all of these signals are coming in, they're connecting with thalamic nuclei. And then we just see these green ones up here. We don't know what those are. You don't know if they're anterolateral cord, if they're posterior column. So are we okay with this one? This is the easiest one we are going to have. Everything after this one gets exciting. All right. Pontine lesion, a lateral pontine lesion, or it could actually be down into this region of the medulla. So it could really be in through here. Well, anterolateral signals coming from the face are lost. No pain in the left face, no temp, no bite, no touch. Oh, goodness. Let's see. So we have this column coming down here, goes on up. We have the other one coming down here, crossing over. We lose that. All right? That's okay. We have these signals coming down, crossing over. We lose that. If this signal coming down, crossing, we lose that. We don't lose this. And the reason you don't lose that is because that is mid-pontine, specifically a lateral pontine lesion. If it's going to involve the medulla, you don't lose that. All right? Is this making some sense?
Where is the vibration sensation dog for the face?
So the red,
It's the red of the face.
the posterior column. No, you don't. That's supplied by a different nerve. That's not supplied, it's supplied differently. Was that the question?
Yeah.
Yeah, no. That sensation has a different pathway. So. So now we've got this medial medullary lesion. In general, what you're going to lose here, okay, once, this is weird because the lesion they're showing you here is literally here. It is not crossing to the other side. Has to do with blood flow. Okay? So what you're doing here is you're only affecting these. The posterior column. That's it. Okay? So we're losing posterior column. In theory, we can affect some of the anterolateral as well. I would never separate those out for you. I would never say, oh, you only lose one. I would say you lose somatosensation. Anytime on the exam, if I say you lose somatosensation, the assumption you will make is that you're losing both the anterolateral and the posterior column. Unless I specifically give you something that says, you lose pain sensation, you lose touch. Oh, touch. If I say touch, you've got to assume both, right? Okay. Ugh. Here's an interesting one. Symmetrical polyneuropathy. In general, symmetrical polyneuropathies are going to be the result of diabetes. There's almost no other way you can have this any other way. You can have losses that are occurring at or near the wrists this is one of those scenarios